Today we're going to solve some simple radical equations. To do this, we solve the equation and then we have to check for extraneous solutions. So extraneous solutions are really important. Those are solutions that don't belong, solutions that don't make sense with our final answer. So first thing we're going to do is solve the equation. This equation, square root of the quantity x minus 3 plus 5 equals x. To solve this equation, we first want the square root stuff on one side and we want everything else on the other side. So what I'm going to do is I'm going to subtract 5 from both sides, and we're going to get the square root of x minus 3 equals x minus 5. To get rid of the square root, the inverse operation is to square it. So I'm going to take this and square it, and I'm also going to square x minus 5. Then I get x minus 3 equals x squared minus 10x plus 25. Notice it's a quadratic equation. I'm going to bring everything over to the same side of the equation, so I'm going to subtract the x and add 3, so we get 0 equals x squared, subtract x minus 11x, and we're going to add 3 plus 28. How do we solve quadratics? Well, factor them if we can. So 0 equals x minus 7, x minus 4. Hopefully you figured that one out pretty quickly. Then we just solve for x. So x minus 7 equals 0 and x minus 4 equals 0, or x equals 7 or x equals 4. To check for extraneous solutions, we want to take both 7 and 4 and we want to substitute them into the original equation and see what makes sense. So my original equation, square root of x minus 3 plus 5 equals x. So if x equals 7, I get the square root of 7 minus 3 plus 5 equals 7. Well, 7 minus 3 is 4, and the square root of 4 is 2. So 2 plus 5 equals 7. And that checks out because 2 plus 5 is 7. That makes sense. We also have, if x equals 4, we want to check that as well. We have the square root of 4 minus 3 plus 5 equals 4. So 4 minus 3 is 1, the square root of 1, so we get 1 plus 5 equals 4. Guess what? That one doesn't make any sense. So that one is an extraneous solution. The only solution to this really is x equals 7. Does that make sense? If it doesn't, bring me questions. We're also going to look at the next one. So the next, I've got another example here, a little bit more advanced. We have square root of quantity 3x plus 2 minus the square root of the quantity 2x minus 7. This is a little bit different from the other one because I've got two square roots. The way to solve this one is to put the square roots one on each side. That always helps us out a little bit. So square root of 3x plus 2, and then I'm going to add the other one to the other side, so I get equals the square root of 2x minus 7. Get rid of the radical sign by squaring, so I'm going to square both expressions, and we get 3x plus 2 equals 2x minus 7. We solve this just like a normal equation, so I subtract 2x to get 1x plus 2 equals negative 7. Then I'm going to subtract 2 from both sides to get 1x equals negative 9. So x equals negative 9. That's the only solution we get the way this is set up. So the last thing we need to do is check for extraneous solutions. Always, always, always check to see if your solution makes sense. So I'm going to substitute it back in for x, and I get the square root of 3 times negative 9 plus 2 on the one side, so that's the square root of negative 27 plus 2, or the square root of negative 25, which is 5i. Hopefully we don't get similar things on the other side, but we'll see. We have the square root of 2 times negative 9 minus 7. That's the square root of negative 18 minus 7. Square root of negative 25. Guess what? We get 5i on the other side as well. So this is a valid solution if we're looking for imaginary numbers as well as real. So be careful. In this case, negative 9 is an extraneous answer when we're looking for real numbers. So be very careful. So it's extraneous because it's not real. Okay? So we always look for real solutions to these things. Okay? Let me know if you have any questions, and feel free to bring them to class.